Today we're going to take a second look at quadratic formula, how to use it, and then of course what we're solving for when we use it. So the first problem was actually taken from yesterday's notes where we took a look at this equation that represents this path of the baseball once it's hit. And so in this problem the baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees with respect to the ground. The path of the ball is given by this quadratic function, negative 0.0032x squared plus x plus 3. So you can see a kind of a picture of this situation. Here's the batter hitting the ball at a point 3 feet above the ground. The ball is going to go up, and then it's going to eventually land on the ground right here. We can see why the a value is negative because it's a frowny face graph. The 3 right here is the 3, the height above the ground. So we can see that represented in the equation as well. So our goal is to figure out how far away does that ball land when it hits the ground. And we're going to round our answer to the nearest tenth. All right, and f of x is the height of the baseball. So we want to know, when is this height 0 right here? And we're solving for x. And essentially what we're looking for the x-intercepts. Now we could try to factor this and use zero product property to solve, but factoring this, like putting this in a box, and then using the diamond and then trying to get the outside, that's going to be hard with that negative 0.0032. So if we use quadratic formula, it will also give us the x-intercepts. Now in order to use quadratic formula, the first step is make sure you have 0 on one side, and we do, because we want to know when that height, f of x, is 0. So 0 is on one side. Second step is we're going to identify what is a, b, and c. So I'll write that over here. A is the number next to the x squared. So here in this situation, a will be the negative 0.0032. B is the number next to the x, and if there's not a number there, it's going to be a 1. So this will be a positive 1. And then C is the number without an x, the number by itself. So here the C value is 3. And if you remember quadratic formula, it's x equals opposite b, so I'll write it down. Do I have room right here? I'll write it right here. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And so we're just going to plug in. We have a, b, and c. We're going to plug in. So you have x equals opposite of b, which is negative 1, plus or minus the square root of 1 squared minus 4 times a, which is negative 0.0032, times our c value, which is 3. And notice everywhere I'm plugging in, I'm putting those parentheses under the radical, all over 2a. And again, a was negative 0.0032. All right, our next step that I would like you to do is to actually solve for this thing under the square root sign, under the radical. It's called the discriminant. But if we can get that number, this first number, and this bottom number, then when we type it into our calculator, we're less likely to make an error. So we have x equals negative 1 plus or minus the square root of, and I'm just going to go ahead and type that in. So I'll use my calculator. We'll do 1 squared minus 4 times a, which is negative 0.0032, times c, and the c value was 3. Okay, so there's that number under the radical, 1.0384. Write that in, 1.0384. And then all over 2a, so I wrote that in right there. And then the bottom is 2 times negative 0.0032, so I can multiply that out. That ends up being negative 0.0064. So if we can get those 3 numbers that I circled in blue, then it should be a lot easier to calculate our answers. Now, to calculate the next step, I'll do the top part first and then hit enter and then divide. So I like to do the positive first. So I'm going to type in negative 1 plus the square root of 1.0384, hit enter, divide by negative 0.0064. So here's what it looks like when I type it in. Let me clear this real quick. Okay, so it was negative 1 plus the square root of 1.0384. And then I like to hit enter. And then I'll divide by that bottom number, which was the negative 0.0064. And here's one of our x-intercepts. It's negative. Okay, so let me write it down first, and then we'll talk about what it means. So negative, I'll round to the nearest hundredth, so negative 2.97. Okay, and then I'm going to do the other one, which was is negative 1 minus the square root of 1.0384 I'll hit enter, and I'll divide by that negative 0.0064. Right, this one's positive, and I'll write it down, 315.47 if I round to the nearest hundredth, which is 2 after the decimal. All right, so let's talk about what we got and what it means. So again, we got one answer that was negative and one that was positive. So if we're looking at the x-intercepts here, I know that here where it lands is going to be the positive one, the 315.47, which means that's how far away from home plate that ball is when it lands. So it seems like it would be a home run. All right, and then we'll talk about the other one. The other one's negative because we're starting at this height of 3 right here. So if we extend the parabola, we can see why it actually ends up being that negative 2.97. Because we're starting at that height of 3, it does kind of shift the x-intercept into the negative region. All right, so we have solved, and we could say, all right, that ball's going to land 315 feet from home plate when it lands on the ground. So finding the x-intercepts, the zeros, it's finding where it lands on the ground. Okay, let's take a look at number 2. A rocket is launched from a tower. The height of the rocket y in feet is related to the time after the launch x in seconds. So here our answer is feet, and then the time here is in seconds. Using this equation, whoopsies, find the time that the rocket will hit the ground to the nearest hundredth of a second. Okay, so again, if we're talking about the launch as being launched from a tower, here's how tall the tower is, because that's at time 0. So we have this tower. It's being launched, it goes up, and then it goes down. And so we're trying to figure out, actually I didn't make my graph too great, did I? Let me redo that. Okay, so where it launches from, that's the y-intercept. And then we're looking for where it hits the ground. That's the x-intercept. Here's the vertex. But here's what we want. Find the time that the rocket will hit the ground, the x-intercepts. Notice, since again we're starting at that taller height, one of our answers will be negative again, so we're looking for the positive. All right, so again, when it hits the ground, this is a 0. That's the first step of quadratic equation, or solving with quadratic formula. You want 0 on one side. And the next step is to find a, b, and c. A is the number next to the x. Here it's negative 16. B is the number with the next to the x. Okay, sorry. A is the number next to the x squared, the negative 16. B is the number next to the x, 240. And C is the number by itself, the 115. And then we plug into quadratic formula. So we have x equals opposite b plus or minus the square root of b squared minus 4 times a times c all over 2a. And again, I would like you to calculate these 3 numbers separately. You have your negative 240. I want this number underneath the radical sign, the square root sign, and then this number on the bottom. So x equals negative 240 plus or minus the square root of, and I'll just type this in my calculator because I don't know what that is. So we'll do the 240. Notice I'm not writing the square root, just what's underneath. So 240 squared minus 4 times a, which is negative 16, times c, which was the 115, the starting height. Okay, we're going to get 64960. 64960. And all of that is over 2a. 2 times negative 16 is negative 32. All right, now we split this up and we get our 2 answers. And again, when we type it in, I like to do the plus first. So I'm going to type in negative 240. Let me do this with my calculator over here. So I'll do negative 240 plus the square root of 64960. I'll hit enter. I'll divide by the negative 32. And here I get a negative. So one of our answers is negative, so x equals negative 0.4. And what's the nearest hundredth of a second? So that's 2 after the decimal. So if I round it, it's about negative 0.46. And then the other one, if I calculate, we will do negative 240 plus the square root of 64960. I'll hit enter. I'll divide by that negative 32 again. Oops, I did plus again. Sorry, let's do minus. So negative 240 minus the square root of 64960. Hit enter, divide by negative 32. That's the answer I want. It's about 15.46. So again, we get 2 answers. We're looking for the positive one. We're looking for this guy over here, which is the 15.46. That's how many is it, seconds? how many seconds it takes to hit the ground. One of our answers is negative because the height is at 115 when it starts. We can see our parabola being shifted to the negative. So that negative 0.46, we're not really going to look at for this one. Here our answer will be 15.46. All right, so we've taken a look at two situations where you might use quadratic formula to find where something hits the ground. And so remember, again, one more hint, and then I'm going to give you some time to work. There's 5 problems for you to try. The hint is, don't forget to get 0 on one side first. In the word problems, it was just automatically set to 0, so we could solve. But let's do one that's not set to 0, and then solve that one in example 3. So solve the equation, solve the quadratic. And again, first step is we do need 0 on one side. We have a negative 8x. How do we make that a 0? We're going to add 8x to each side. So there's our first step. We'll get x squared, and then negative 24 plus 8 will give us minus 16x plus 47 equals 0. Now we can use quadratic equation to solve. Okay, so again, once you get 0 on one side, then you can identify your a, which is the number next to the x squared. And if you just see an x squared or an x by itself, it's a 1. So the number next to the x squared is a 1. The b value is the number in front of the x, the negative 16. And the c value is the number by itself, which is 47. We're going to plug into quadratic formula. So x equals opposite b, and here b is negative, so now it's positive, plus or minus the square root of b squared, notice I'm using parentheses when I square that negative 16, minus 4 times a times c, all over 2a. And again, I do want you to calculate these numbers separately so that when we type it into our calculator, we make less of an error. So 16 plus or minus the square root of, and I'll do parentheses, negative 16 squared. And again, the parentheses are important because a negative times a negative is a positive, and if you don't tell your calculator that, hey, it's this negative 16 that you want to square, it'll do 16 squared first and then multiply by negative 1. So we get negative 16 squared minus 4 times, actually I'm going to show you on my calculator what I'm doing, so give me a second here. Okay, so when I type this in, here's what it looks like, just the number underneath the radical. Look at this. All right, so here it is. Negative 16, we'll square it, minus 4 times a, the a value was 1, times the c value, which was 47. So there's the number exactly as I wrote it underneath the square root sign, and that's 68. So we'll put the 68 under the square root sign, all over 2 times 1, which is 2. Now we can go ahead and type this into our calculator, and we'll get 2 answers here. So the first one I'll do 16 plus the square root of 68. I'll hit enter, I'll divide by 2, so it's about 12.12, and the other answer is 16 minus the square root of 68. I'll hit enter, I'll divide by 2, and it's about 3.88 if I round to the nearest hundredth. So 2 answers here. I should really write x equals, so x equals about 12.12, and x equals about 3.88. Oh, and if you're doing this assignment on Delta Math, it wants you to write your equation in set notation, so I think you would just put in parentheses. Let me see how they want you to write it. Give me a second here, and I'll pull up the Delta Math, and we'll see. We'll see how they want you to write the 2 answers. And again, the reason why there are 2 answers while we wait is if you notice, this quadratic is a smiley face because the x squared is positive. So this is saying at 12.12 and at 3.884, that's where your quadratic is going to cross. So that's why we have the 2 answers, because it crosses twice. Okay, so did it load? Yes, it did. Let me just pull up this problem and see how it wants you to format it. So I think it was like this one right here. Okay, so here was the problem that we did. We added 8x to each side. We used quadratic formula. And for the answer, it says write as a solution set. So x equals that curly bracket, 12.1, 3.9. Oh, they rounded to the nearest tenth. I did 100th. All right, let's see if I can type that in the way that they want. What if I just put in the answers? 12.1, 3.9, will it? Oh, it automatically does that for you. Okay, so there it is. And we can check our answers. So that's the solution set. Okay, so you'll see those curly brackets as part of your problem. All right, so your assignment then, either if you're in class, I have it on a worksheet and I'll hand that out. You can also choose to do it on Delta Math. But if you're at home, you can use the Delta Math then to put in your answers and to also check your work. So same problems in class and also on Delta Math. You have 3 problems where it's just get 0 on one side, find A, B, and C, plug in, get your answer. And then you have 2 word problems that are like the rocket problem that we did before. So 5 problems, get those done. You can check your answers on Delta Math and let me know if you have questions. And that's it.